last question for the morning comes from Sasha, who we know. Yeah, who is a solid viral immunologist. All right. And so, the question is, what do you think of this paper, this study? And so I look up the study, and it's in medRxiv. And the study's title pretty much tells you what the study is about. It's called Test Sensitivity is Secondary to Frequency and Turnaround Time for COVID-19 Surveillance. So, what does that mean? Yeah, so this is a mathematical modeling study, and once again, I can't really comment much on the mathematical modeling itself. I'm not in a position to recognize modeling that's been well done or poorly done. I guess if you do it badly enough, even I might notice. But yeah, no, most of these people are pros, and good for them. Yeah, that's fine. But the contention is that there are two ways to approach this thing. You could say, well, we've got this lag period. We know that the person is exposed to the virus, and then we don't know the exact amount of time. The low end might be about 4 days after, and the high end might be about 10 days after when you can first detect the virus for real inside this person. And the person will have the virus every day up to that point, but they won't have enough of it in a place where you are likely to be able to accurately find the virus. Yeah, it's hide and seek, and it takes a while. Yeah, because the tests are the seekers. Yeah, and the virus is very good at hiding. So this is modeling different things. It says, well, what if you could make the test more sensitive? And so instead of having to wait until day 4, what if you could detect it on day 3 at the earliest? And just get everything a day earlier. Or, what if you were able to improve it maybe a little bit more than that? As compared to, well, what if we took this problem and looked at it a different way? Because around the world, including some people that I know, some of these tests for SARS-CoV-2 have been taking a long time to come back. Depends where you are, but wait times of 3 or 4 days are not uncommon. Occasionally, somebody will be able to turn it around within 24 hours, which is awesome, yeah. But that seems to be about the quickest, and I've heard of a case, where it was something like 2 weeks to get a rapid antibody test, which is insane because the test takes 5 minutes or something? And that's only if you like drama and like waiting until the last possible moment to look. Yeah, because you can tell before that. So, yeah. And so the paper is looking at the delay, and they said, well, what if we could shorten the delay down? Because, of course, some of these people are now being tested at a point where they have symptoms. And so they think they might be sick, but they don't know for sure. Or where you're going out and proactively testing all the people in a particular nursing home, for example. And so at that point, does time... where is time more valuable? In cutting down one delay or in moving the first detection point a little bit earlier? Anyway, what they conclude is that, based on the way tests are being done and the number of people who are testing positive, you basically got a lot more people in that category, and it's a lot more certain, and they probably have a lot more virus that they can spread to others. And in some cases, they're sitting there at the peak of viral output when they're producing more virus than they ever have before. And they're just waiting. They're waiting for a test to come in. And so, I think the fairly sensible conclusion from this paper is that improving the sensitivity of the tests, like being able to detect earlier, is probably less important than cutting down the wait time. And so, for new test development, this is a pretty good thing. They would advocate, rather than looking for increased sensitivity, find a way to just reduce the amount of time it takes to do the test. So make it simpler. Make it something that can be done in more places, doesn't require specialized equipment. Make it something that can be scaled up. So if you can do 500 in the time that you used to be able to do, 250 or 100, that's a big win. Every little savings in efficiency here translates to potentially letting somebody know that they have COVID or don't, sooner. And yeah, that just means fewer infections, and that could potentially turn this around. So this is a nice little, it's almost an engineering approach. Make the process more efficient and achieve better results, yeah, from your process. Fantastic, yeah. Somebody here's a Six Sigma black belt if I'm even using those weird words in the right way. But yeah, I get it. Makes sense. I like it. I like the idea. And I hope this is the next thing that we see. So we've seen a lot of people trying to do basically the same thing in slightly different ways. But most of these have had the problem in that you either get a yes or no test that's not as informative, or you get a test that is real accurate and kind of slow. And yeah, both of those can be improved. Thank you very much, and I hope everything is going well for you where you are. Yeah, heaven knows things are pretty rough here right now. Take care. Thanks very much, and this has been Ask Dr. Ben.